Continuing with chapter 12, here we are with the volume of spheres. Think about what we've talked about so far with cross sections, okay? A flat surface slicing through part of your 3D solids. So if you look at this sphere, right, you notice if you take a flat surface like a plane and slice through the sphere, the cross section that you're making are circles. The farther away you get from the center of the sphere, the smaller the circles get. The closer you get to the center of the sphere, the bigger the circles get. If you slice it right down the middle so that you make two equal halves of the sphere, which are called hemispheres, that circle is called the great circle. Okay? So if you look at example 1, don't worry about the numbers yet. Again, feel free to pause it and write them down if that's easier for you. Just look at the picture first. This circle here, this is the great circle of the sphere. It's the largest circle cross section we can make. It's right through the middle if we slice through it. Okay, so whatever the radius of this great circle is, that's going to be the radius of the sphere. And if you look here at the volume of a sphere formula, is 4/3 times pi times r cubed, r to the third power, not r squared. So that's the r we're talking about. Okay, you can't just slice off this cross section and tell me the radius of that. We want the radius through the middle of the sphere. Okay, so example 1. And this one's clear. The radius is 6 centimeters. So I do the formula. The volume is going to equal 4/3 times pi times 6 cubed. And when I'm evaluating this, okay, I have to do this exponent first. So I do 6 raised to the third, and that's 216. And then it's 4/3 times 216 times pi. Remember from earlier, when they want the exact volume in terms of pi, you're going to leave the pi in your answer. So while I'm doing this here, I kind of ignore this and just do the 4/3 times 216, which of course is going to be like this. 4 divided by 3 times 216, 288. So that's where the 288 pi came from. Now, since the length here is in centimeters, the volume is going to be in centimeters cubed, as always. That's the exact volume. If I wanted you to round it, you would just go back to the calculator and just do 288 times pi. And then you round to this decimal place. In this case, it would round up. So that's where we got this answer. Example 2 is exactly the same, except they're giving you the length of the diameter of the great circle, which is 16 meters, and we want the radius. So you have to divide that by 2 to get 8. Once I get that, I'm going to substitute it into this equation, 4/3 pi r cubed. Now if you get to this part here, okay, it's not always, like 216 was divisible by 3 in example 1, so that's why we could get a nice, round number here to multiply by pi. That's not always the case. So sometimes if they ask me for exact, I'm going to leave it as just a fraction. So what I did here, again, I leave the pi for now, and I just did 4 times 512, and you can kind of treat it like this here is a fraction over 1. So I just multiply that, and it's 2048 pi all over 3. So they did not ask me for the exact volume in example 2, so I'm just going to take this and type it in my calculator. So I'm going to do 2048 times pi, enter, divide, 3, enter. There we go. And you have kind of a built-in check for this because pi is a little bit more than 3. So if I'm starting off with 2048 and I'm going to multiply by pi and then I'm going to divide by 3, my answer is going to be a little bit higher than 2048, and as you can see, it was. Okay? Continuing along. Example 3, same thing. Don't be fooled. They're giving you the length of the diameter, which is 22 inches. We want the radius. It's 4/3 pi r cubed. So we need the radius. So we do 22 divided by 2 is 11 inches for the radius. And that's what we substitute into the equation. Once we're there, I'm going to do 11 raised to the third. Like that. And then I have to do times 4, which gives me 5,324. Keep the pi next to it, and then it's all over 3. This right here is what I would type or write if they asked me for the exact answer. But they didn't. They want me to round it. So I'm going to go back to my calculator and I'll do 5324 times pi. Enter. Divide 3. Enter. And I should end up with a number that's a little bit higher than 5324. And here it is. Okay. Example 4. As you can see, so far there's not much variation. The only thing you got to look out for is 1. If they give you the diameter, you have to divide by 2, like they did again in example 4. 9 divided by 2, 4.5 centimeters is your radius. The other thing is, you got to make sure you type it right in your calculator. So make sure you do, once I substitute, I got 4/3 pi r cubed. Do the r cubed first, enter, then times 4/3, enter, and then divided by pi. I'm sorry, by 3. This is the exact answer. They don't want that. They want this. So I do 364.5 times pi, enter, divided by 3, enter. And then you'll get this answer. Now I'm saying it that way because, like, no matter what calculator you're using, if you do it that way, it will work. I'm using a graphing calculator here, so obviously I can type things in a little bit longer, before needing to do that. I could actually do it like this. And then times pi, whatever. There's more than one way to do it. It's just the way that I'm saying it, no matter what calculator you're using, you'll get it right. If you just do 364.5 times pi, enter, divide 3, enter. Here you are. Now, this one's a little bit different, okay? In that, put this up for you. In this one, we're going to give you the volume, and then we want you to find out the radius. Well, the volume is 4/3 pi r cubed. So you write that out, but instead of putting v, you're going to put what they told you v equals, which is 36 pi. And now we're trying to solve for r. We're trying to find the radius. So how are we going to do that? Well, first we just divide out the pi. So that's what I did. And those will just cancel out. So now we're down to 36 equals 4/3 r cubed. Before we can get rid of the exponent, we have to get rid of that multiply by 4/3. So how do we do that? Well, you either divide by 4/3, or if you're trying to divide by a fraction, remember you just multiply by the reciprocal. So I'm going to multiply both sides by 3/4. That will make these cancel out. So I'll just be left with r cubed on the right side of the equation. And then 36 times 3 divided by 4 is 27. Now, if you think about it, you've done this more in algebra too. When you have an r squared equals a number, or an x squared equals a number, and you're trying to solve for that variable in algebra, you want to go from r squared to r, or x squared to x, you do the square root, right? Well, if you have r cubed, and you want to turn that into r, you have to do the cube root, okay? So if you think about the square root, it's what number multiplied by itself twice equals that number. So if I said, what's the square root of 25? You'd say, oh, 5 times 5 is 25. So the square root of 25 is 5. The cube root is what number multiplied by itself 3 times equals that number. So what number multiplied by itself 3 times equals 27? Well, that's 3. 3 times 3 times 3 equals 27. So to go from r cubed to r, I'm taking the cube root of both sides. It's a square root with a 3 above it. So the radius is 3. And now you could always take this 3, substitute it back into the original, and see if you get that 36 pi per volume. Hemisphere, we're trying to ask you how much water is going to fit in this bowl. Well, it's half of a sphere. We already know the formula for a sphere, which is 4/3 pi r cubed. So we're going to do half of that. So we're going to do 1/2 times 4/3 pi r cubed. That's what this looks like. But you can also keep in mind that half of 4/3 is 2/3. So the formula for the volume of a hemisphere is just 2/3 pi r cubed instead of 4/3 pi r cubed, like the sphere. Don't forget, 20.7 is the diameter. You want the radius. Substitute your numbers in, and then round. Refer back to these numbers. If you're typing in your calculator and you're getting a different answer, then make sure you talk to your teacher about that, about the calculator you're using. Make sure you get that straightened out. Because the last thing you want is to have all the setup correct on a test, and you're losing points because you're just not typing something right into the calculator. And our final example is like we've seen a little bit before with the composite solids. This is, a snow cone. It's a cone with a hemisphere on top, and I want to know what's the total volume of the whole thing. So we're going to do the volume of the hemisphere. We're going to do the volume of the cone. And as you can tell, the radius is the same for both the hemisphere and the cone. Here's the hemisphere, 4 centimeters. Here's the cone radius, 4 centimeters. So again, we're going to do 1/2 times 4/3 pi r cubed, or if you just remember, that's the same as 2/3 pi r cubed. Right? Do 4 times 4 times 4 is 64. Times 4 is 256 pi over 3. And then I'm multiplying by half because it's a hemisphere. So that's why I just multiplied across and I put this 6 down here. And then if I'm going to round this fraction, I get this number here. Units are cubed because it's volume. For the cone, we already said the radius is 4. The height is 10 centimeters. This is the height. So that's 1/3 times pi times r squared times h. R is 4. H is 10. Here's my exact answer. Here's my rounded answer. What's the volume of the whole thing? Well, I just do this. Okay, so I'll show you how I would do that. I would go 256 pi, enter, divide 3, enter. That's this one. I'm going to divide by 2 more because it's supposed to divide by 6. Well, that's this one. Now I need to add 160 pi divided by 3. So I'm going to take that answer, I'm going to add 160 pi divide 3. And that's our answer. The reason why I did that, this one was just asking for the rounded answer for the hemisphere volume. This was just asking for the round answer for the cone volume. But when you ask me for the volume of the composite solid, I don't want to round once, round again. I only want to round one time. So that's why I typed in the 2 exact answers to get this answer. Okay? So it's volume of the sphere, 4/3 pi